And now let's discover the second side of the communication, which is, well, from your computer to your Arduino. So this will be very useful when you want to make your program more dynamic. For example, you want the user, so for example you, to give some data, so some numbers or some text, etc., to the Arduino while the program is running, so you can modify the behavior of the program on the run. And so in this lesson, I'm going to show you how to do that. So first, if you open the serial monitor, so we still have the old program running, but I'm going to just remove everything, load a new program. So this does nothing. Here you already know the serial monitor, and you know that here on this panel, you will have the text from the Arduino to your computer. And you can see that on the top here, you have a bar, okay? And this is where you can send some text. So let's say I want to send number 12 to my Arduino. I'm going to write 12 and then press enter or the send button. And this will send the data from the computer to the Arduino. So as you can see for now, well, nothing happens because simply I haven't told the Arduino to actually read the value, okay? So you can just send value, but the Arduino will not read them. All right, so now how can we receive inside the Arduino the value that we send from the serial monitor? So the first step you should do, of course, is to initialize the serial communication. So when you do serial.begin, it initializes the communication for both sending data and receiving data. And now what I'm going to do, I'm going to do this in the loop, okay, so we can continuously check if we have new data available. To know if you have data, actually, you have a function from the serial library, serial.available, and you can see it turning orange, okay? So, of course, with parentheses. Serial.available will give you a number, and this number corresponds to the number of bytes that are ready to be read. So now it's quite easy how to know if we have data to read. Well, we simply need to check if the result we get from the serial.available function is strictly greater than 0, okay? If there is no data, this will give you 0. If you have some data, you will get a positive number, and from there we can read the data. So this is a two-step process. First, you check if there is some available data, and then you read the data. And I'm going to show you a few different functions you can use to read the data. So let's say you expect an integer. Let's name it var for variable, because this is just a test for this lesson. If you wait for an integer, you can use the function serial.parseInt. Okay, so this will read the data from the serial and it will parse it as an integer and thus return an integer. So you have an int data type. And now, once you have this value, you can do, well, whatever you want with it. So for example, we could just reprint the value. So serial.println with the variable. Okay, so what have we done with this program? Well, this is a simple echo program. So you send data on the serial monitor here, and then the Arduino will receive the data, and it will print the data. So the data you send here, you will receive it here. So let's make a try. We are going to upload the program. So make sure the program is uploaded to the Arduino, and then, so I'm going to send a number. Let's say I send 42. I press enter, and I see 42. Okay, so what happened in the program? So first we initialize the serial communication, right? 9600, it's the same as here. We enter the loop, then we check continuously very fast if there is some data available from the serial. So of course there is no data. I send the number 42. The Arduino receives the data, and now serial.available gives a positive number, so we enter the if. The function serial.parseInt will read the data 42, put it inside the var variable here, and then with serial.println we just send back the value we received. So you can try with different numbers, etc. It will work every time. If I send, let's say, some text, what happens is that this is not a number, okay? So the parseInt function will simply return 0. So you will get 0. And now one very important thing to check is the option here you have at the bottom, this one. So I have no line ending, and this is what you should have. Okay, this option is actually what the serial monitor will do once you send an information here. So with no line ending, it will just send the data just like you write it. But if you add, for example, new line, let's say I have the new line option and I send 42 again, and oh, we have 42, but we have 0 after that. Okay, let's send another number, 7 and 0. So what happened here? What happened is that when you send a number, so if I send 42, new line will add a new line character. The new line character is \n. So this is what will be sent to the Arduino. And the Arduino will first read the number 42, and then it will read this character, which will be evaluated to 0. So that's why you have the first character and then 0. Okay, so you have new line, you have carriage written, and both new line and carriage written. Make sure you select no line ending, so when you send a number, you just have the number and not an additional 0. Okay, this is a quite common error you can get in your programs. So now you know how to solve that. So now let's make a few experiments. So we have an integer. Let's say I want to send a big number. So you know integer, the max value of integer is 30,000 something. You don't need to be very precise, you just need to know it's in that range. Let's say I want to send 50,000. I'm just going to press enter, and oh, we don't get 50,000, we get minus 15,536. This is because the integer here has overflowed. So we have reached the maximum value, and then what happened is that the value went back to the minimum, and that's why you have a weird number here. So if you want to receive larger number, you need to use long. So let's send 50,000 again, and now you will get the correct value. Okay, so you can receive integer, long numbers, but you can also receive double or float data type. And to do that, instead of parseInt, you will use parsefloat. And it's quite easy not to make a mistake because this will turn orange. Let's plot this, and let's send 3.14, and we get the correct value. Okay, if I just send an integer number, you will see we have an integer, but this is actually represented as a float number, okay? 42.0. So you have parseInt, parsefloat, and if you want to send a string, well, this is a little bit different. You have to use read string. And of course, the data type should be string with an uppercase. Let's try this. Okay, and let's send hello from the computer. And we get hello from the computer. So that is quite convenient. parseInt, parsefloat, and read string. Make sure you have the correct data type, and then you can process the data and do whatever you want in your program. Okay, just one thing I want to show you. I'm just going to send back some text, and just pay attention to the duration between the time when I send the data and the time when it is printed here. Okay, so I'm pressing enter right now, and you can see here the text appears after about 1 second. Okay, one time again, I press enter, and it's not directly here. Okay, it's here after about 1 second. And why is that? This is because of the serial timeout. So there is a timeout for the serial communication. What is a timeout? Basically, when you do parseInt, parsefloat, or read string for those functions, for example, serial will try to read and interpret the data, and because it has a timeout of 1 second, it will simply wait 1 complete second So it can receive all the information and then pass that information. So this is just in case the data is not just arriving at the same time and is a little bit delayed, which can happen with any kind of communication. But here, for our use case, well, we just send one piece of text or one integer or one float, and that is sent very, very rapidly, okay? So in order to reduce the time that is spent here on that function, we can here do serial.set timeout, okay? Again, it turns orange, and set a timeout in milliseconds. So the default one is 1000 milliseconds. Let's put simply 10 milliseconds, okay? It means that when we use the read string function, this will simply wait for 10 milliseconds to be sure we received all the data, and after 10 milliseconds, any new data will be discarded, but that's not a problem because when we send it here, the data will take less than 10 milliseconds to arrive. So in this case, we will save almost 1 second when using that function. And one important thing is that first, so you do serial.begin and then serial.set timeout. You just do that once, okay, after serial.begin. Now let's upload the program. And I'm just going to write some text again. And now I press enter. And you can see the text here appears almost immediately. Another time. Okay, almost immediately. In fact, it appears with a 10 millisecond delay. Okay, and that is the same, so the timeout will behave the same for a read string, for pass float, and for pass int functions. Alright, so now you know how to receive and read data from the serial communication on your Arduino board. And just to show you how you can work with serial communication on Tinkercad, so for the simulation, well, you have seen that in the serial monitor here, you will just see the data when you have serial.print or println, for example. And here is actually where you will send data from the computer to the Arduino board. So that's quite similar to what you have with the serial monitor with the Arduino IDE. So here is the same code I've used. I'm going to just start the simulation here. Okay, send this of string, press enter. So it goes to the Arduino and then the Arduino prints it and you can see hello on the serial monitor.